All right. Our next speaker, you may know him from RxJS, the reactive library on JavaScript. You may also know him from his open source framework called CycleJS. You may also know him from his open source off-the-grid social network that he's working on right now called Manyverse. And recently, when TC39 played around with the idea of adding this horrible Smush and Smush map, Smushgate it was called, to our beloved programming language JavaScript, he started a revolution to prevent that by creating a library called Prevent Smush. You may know him from that too. One of the most prolific JavaScript developer that I know. Here is Andre Staltz.
Okay. Hope you had a nice lunch. Glad to see you all back in this auditorium. It's an amazing place. So as you see, the title of this talk is Profunctor Optics for State Management. Now, some of you have no idea what this talk will be about. Is that you? No idea? It's a lot of people. So Profunctor Optics are this term that scares a lot of people because it's on purpose. No, it's not on purpose. The thing is that it's known to be very hard thing in functional programming. So hard that even Ken Wheeler decided to make a title of a song called Profunctor Optics in his album because he thought, what is the most hardcore thing I can get? And then it was Profunctor Optics. And this is a bit exaggerated, but some of it is true, though. It is quite hardcore. Actually, there's a thing called the standardized ladder of functional programming, which is kind of like a curriculum of all the functional programming stuff you need to know in languages such as Haskell, not even JavaScript. They don't mention JavaScript there, and they have a bunch of concepts there, such as in the very beginning you have immutable data and function composition and first class, lambdas, and then you go to algebraic data types and type classes and higher order function currying. And then the intermediate stuff is like generalized algebraic data types and monads and existential types. And then the hard stuff are co-monads and monad transforms and free monads and type families. And then the very hardcore stuff are type level programming, category theory. And at the very bottom, Profunctor Optics. So yeah, it should be kind of hard. And those of you who have done anything Haskell related, you'll be a bit disappointed in this talk because of course I can't go through all of those things in 40 minutes or 1 hour, right? I mean, I can't. Well, I could in 20x speed, but you're not going to follow that. So we need to have a way of shortcutting, going directly to Profunctor Optics and learning this thing, which turns out that it's actually easy. Yeah, it's easy. And it's good that we go directly to it, because why would you spend 4 years learning all of this stuff? And then you finally get to the end and you see, it's actually easy, right? So we could just learn it directly now. So I was learning about Profunctor Optics through blogs and articles on the internet, and I found this one blog which was good, and it had one sentence there which was interesting. It said, a profunctor is just a bifunctor that is contravariant in the first argument and covariant in the second. And there's one important word that makes all of the difference in this sentence. Just. And I know what you're thinking. It's like, this must be sarcastic, right? They must be making fun of me, right? The person who wrote this wanted to hurt my feelings, right? They wanted to make me feel bad and stupid. But try to imagine that you wrote this blog post, and the thing is that why they added just there, because it's actually easy. It's not that hard. So the person who wrote this thought, oh, it's just. So that's what we're going to figure out today, and by the end of this talk, you're going to know 100% what this sentence means. And I semi-promised that. I JavaScript promised you that. So let's go forward and see how could we use this for state management, because, right, we're talking about this plus state management. I'm talking mostly Redux and React Redux and things that are inspired by Redux, such as NGRX. I should have added also Vuex there, and MobX is quite different. Raise your hand if you use something else than this, something very different. One hand in a full auditorium? Right, so we're going to be talking about these things, and I'm going to basically assume that you know Redux, or the basics of Redux, and I hope that that covers most of the auditorium. Okay, so what about state management? I mean, once you start using it, especially something like Redux, it's nice, it's functional, and build the next state object, but you get into some difficulties. Some of them are such as, you have 3 different types of state. One of them is the global app state in the store. The other one, you convert map state to props, and then you get the props, and then you get local state component. And what if you decide, I want to get local state from a component and push it up to the store? Then you need to do some shuffling around. It's kind of tricky how to do this. And then there's, of course, boilerplate with actions and action creators and all the different string types. The store is a singleton, which means it's harder to compose things. Let's say I want to take this piece of my app and publish it somewhere. It's harder to do that with singletons. You also need to carefully design the global app state, normalize it, and decide what goes here, what goes in local state, that kind of stuff. And then there's always connect in React Redux, which you need to sort of select. And that's the selector is sort of like almost like a 4th type. Well, it's basically props, but anyway, it gets a bit tricky. So what can we do about this? I'm going to talk about profunctors, but for that, I need to talk about functors and also bifunctors. Now, some of this you know already, even though the words may sound weird. Functors you probably use on a daily basis already. So for instance, let's say you have a function f that takes a number and outputs a string, right? Just converts the number to the name of the number. Of course, you can take an array of numbers and call .map with f. And then you get out an array of strings, okay? So everything that has .map is a mappable, and that's just another word for functor. There you go. What other kind of functors we have in JavaScript? Well, we have observables from RxJS. Those are also mappable, so they are functors. And we also have, let's say, immutable.js. So just like here, I had an array of numbers, and I mapped them to an array of strings. I could also have a set of numbers that I map to get a set of unique strings. Okay? So that's it. Functor is anything that's mappable. It's easy. Just giving you some context so we are all on the same page. And what it allows you to do is basically, allows you to convert from one context to another. Let's say I have observable of objects. I want to have an observable of strings, right? I convert from this to that, and it's a one-way conversion. What else? Bifunctors. Well, as the name indicates, there's sort of like 2 things going on, or it's like a double mappable. Okay, that's interesting. Let's say you have 2 functions, f and g. So the f does what you saw before. Let's say it takes the numbers and it translates them to Dutch numbers. And this one takes fruits in English and translates to fruits in Dutch, so that you could pass 2 and you get dwie and apple. I don't know Dutch, okay? Take it easy on me. Come on. I'm Brazilian, and I moved to America when I was a kid and moved to Finland, so I didn't move to Netherlands. Anyway, anything that has .bimap is a bifunctor. Now you may be thinking, I've never seen .bimap. Yeah, you haven't. It's not that common in JavaScript. But they allow us to convert from 2 contexts to 2 other contexts. Okay, I mean, so far nothing special, right? It's just bifunctor, so 2, and you get from these 2 contexts to these 2 contexts. But here's an interesting thing. I looked at React Redux. Like, let's say, you import connect from React Redux, right? And then you have your store, and then you have your app component. And what happens here is that you have map state to props and map dispatch to props. Aha. Do you see the same thing that I see? Map 2 times. That's interesting. That actually made me quite curious. Is connect a bifunctor, right? Because it's converting from this context of state or dispatch to the other context of props. Could be a bifunctor. Then I tried to do this thing. I tried to connect and then connect again. So basically, the output of connect will be a component, just like the input was. So I thought maybe I could just pass that component to another connect. But no, this doesn't work. I tried to do this. It just doesn't work. Which is a bit of a shame, because map, of course, composes. You can call dot map, dot map, dot map, and that's fine. But you can't call connect, 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 or in other words, by map, by map, by map, which was a bit disappointing. I mean, connect is almost a bifunctor. I mean, it's kind of like a dead bifunctor. You could think of it, sitting on the old chair, which is Redux or React. Anyway, my exploration ended there, and I thought, yeah, whatever. So it turns out that profunctors are just a special type of bifunctor, and they are real bifunctors. So let me start with the basic example. Let's say you have, just like before, from number to string, and then from string to number. So for instance, I go from here to 1, and then I could go from 2 to 2. Okay? As you see, the type of these, of the output of f is the same as the input of g. Okay? So that means that you can convert from number to string and string to number. And observe carefully, I'm going to flip vertically g. Okay, what happens if I flip vertically g? You get this kind of diagram. So you go from number to string and string to number. Okay? So you can convert from one context to another and backwards. Our goal in this talk will be to show how you can get from parent state to child state and from child state to parent state. Basically, it's essentially map and unmap. That's the idea. Or if you're used to selectors in Redux, it's a selector and an unselector, the two ways. So that's what profunctors allow us to do, to convert from one context to another and backwards. So there are a couple different types of Profunctor Optics, is the name out there, but these are very sort of Haskell-specific stuff. And I'm not going to talk about all of these, except one, which is called lenses, or functional lenses. They're quite common in Haskell, but in JavaScript they also exist in Ramda. I don't know how many of you use or know Ramda, yeah? There's been lenses there since always, I think, or for a long time. And there's also another library called partial lenses. And I think these things are quite solid. I've been using it in a library called CycleState, which is one of the libraries in Cycle.js. And we've been using this for like over a year already. So we're using lenses in Cycle.js in production as well. And we're very happy about it. I'm so happy that I even came and I'm giving a talk about it, okay? So I know what you're thinking. Am I going to teach you Cycle.js? I mean, you're already learning all these complicated profunctors. You're going to learn Cycle.js? I mean, what's the point? I mean, it's like you don't want to change your framework and all your coworkers are going to look at you angrily. And you don't want to learn this framework that no one uses except Andre and some others. So I did something for you. I basically wrote a small library in React so that we can use this kind of stuff in React. So it's called use profunctor state. And as you see, it's using hooks, which are the new stuff, so new that it's even alpha, so it's not yet official. And now you feel nicer. I can see some people, they feel so nicer now that they know they don't need to watch me programming Cycle.js. Okay, so how are we going to use this? I have a simple app here that just displays like a Celsius thermometer, but unfortunately our data is in Fahrenheit. For some reason, you're interfacing with like a backend from America or something, and it's in Fahrenheit. Go figure. And we have this nice thermometer component that we want to use, but we want to show Celsius. But right now it says 70 Celsius. I should show actually Fahrenheit. So I have two functions, Fahrenheit to Celsius and Celsius to Fahrenheit. I'm going to use those just to, F to C, like that. And then it should show 21 degrees Celsius, which is good. But also, I'd like to add a bit more to this. I'd like to add the possibility of making this colder or hotter. And as you see, I'm putting it in the Celsius thermometer. I'm not putting it above, so that basically I want this component to manipulate Celsius. I don't want it to care about Fahrenheit at all. I want it to manipulate Celsius. Now, of course, I could just dispatch an action that goes to some reducer that changes the Fahrenheit and converts back to Celsius, but I don't want to do that. So what we're going to do is use Profunctor state, kind of like use state. You pass an initial object here. It can be, for instance, Fahrenheit is 70, and it could have also other stuff in this object. And what you get out is a Profunctor state. This is an object that has a couple of things. It has state, set state, and promap. Now, I could just use it like this instead, and I could just already, destructure it already. So this is the usual way how people are using these hooks nowadays. Initial state is just going to extract it over there so it looks a bit nicer. Like that. And initial state over here. Okay. So what you can do with state and set state and promap? Well, first of all, I'm just going to, as you can see, my app, well, I'm going to put like a small debugging thing over here so we can take a look what that state is. Also going to JSON stringify it. And this should be state.Fahrenheit. Let's see if that's okay. Yeah, it shows the global app state there. This part, unfortunately, is in American data, as you see, American data. And we need to sort of convert the American data to basically what we have here is European thermometer, right? European, good. So I need to have a conversion layer from American data to a European thermometer and backwards, right? So how do we do that? Conversion layer, right? That's the case for map and unmap, pro mapping. Okay, let's use that. No one got the joke about the Americans? Okay, whatever. So I'm gonna create, I'm gonna use pro map so that we can map and unmap. I'm going to call this Celsius Profunctor, just like I could have called this app Profunctor. Promap, so how do I this is selectors, okay? Map state to props, you know this. So state.Fahrenheit, now it's in Fahrenheit, I just converted to Celsius like this. And then there's a second part of the promap, which is unmapping. And that would be, once I have a Celsius, I'm going to create an object that has Fahrenheit, and I can convert C to F, like that. As you see, from parent to child, and from child to parent. But I have a problem here that my original object had other stuff as well, and I'm sort of losing that, right? So I need to keep that somehow. Lenses, which are a special type of profunctor, they also have this special thing that you have an optional second argument, and that's the old state. Okay? So child, basically new child, and old parent becomes new parent. So I can just object spread all of the old state here. Cool? Let me just format a little bit. Cool, so now I created Celsius Profunctor, and what does it have? State, set state, and promap. I just need to pass that for my Celsius thermometer. So I'm going to say state equals Celsius Profunctor.state, set state. You know what, I think I'm going to actually just object spread. Okay, Celsius Profunctor. So now this will get state, set state, and promap. Right? let's go back up there. It's going to get state, set state, and ProMap. I can use state, which is the number, is the Celsius number, and then, yeah, it's already converting from 70 to 21. Okay, cool. Now I just want to make these buttons work, colder and hotter. Now this looks rather straightforward, right? You have set state, and you have these buttons. Let's just make handlers, right? You could easily do this without even blinking, or maybe with a lot of blinking. It depends. Less heat, and we're going to just set state, get the previous Celsius, and we're going to just subtract 5, or more heat, we're going to add 5 Celsius, and that's what we're going to use here. On click, we're going to do less heat or more heat. Let's see if that works. So I press hotter, it adds 5, and the Fahrenheit updated automatically. So I don't need to actually worry about manually updating the Fahrenheit. You see it's already updating it automatically. That's nice. Okay, so this stuff actually works, right? You use set state just like you would use normal set state. And I want to take this a little bit further. As you see, I'm converting from state to state of Fahrenheit converted to F.C. I'm going to do a little bit sort of not so, I'm going to refactor this a little bit. So first I map from state to state.Fahrenheit. So basically just pick .Fahrenheit, and then I ProMap again. Now that I have Fahrenheit, I'm going to convert it to Celsius. It's going to show to the Celsius thermometer, and then I convert back the new Celsius to Fahrenheit, and now this is new Fahrenheit, and I just put new Fahrenheit over there. Right? It's just a two-step process where first I pick .Fahrenheit, and then I will unpick .Fahrenheit, basically putting Fahrenheit back. So this is just literally, what this part is saying is pick something or put it back. And this is saying convert back and forth from Fahrenheit to Celsius. And this works. This composes and still does the same. Well, that's cool. So now you see this stuff is not that hard, right? This is profunctors. So let me challenge you again with that sentence. Profunctor is just a bifunctor that is contravariant in the first argument and covariant in the second. What does contravariant mean? It follows the same direction. Covariant means follow the opposite direction, in a nutshell. And there you go. Of course, we had the situation where we just flip around G, so the first part is contravariant, follows the same direction. The other part is covariant, follows the opposite. And it's a bifunctor. There you go. It's just a bifunctor that's contravariant to the first. See, it's not that hard. So let's give this thing a spin. Let's try it a little bit more on something more interesting. I'm going to make a small to-do app. Objective is that I type something here and insert, and type something else and insert the B, to-do apps. I'm not going to have that there. And I have just this template, very simple, input, button, and list. Let's start with getting a state and set state and ProMap. From use, Profunctor state, the initial state. The initial state is going to be to-do, which is a field that describes what is the currently ongoing typing, and the list, which is an array. And okay, now let's just put some debugging global app state over here so we can know what's going on. Whoops, good. Yeah. Yeah, there we go. So now, as I type here, I should show something in this to-do, right? I need to update that. So I'm going to go ahead and create my pro input, you could say, which is a function, component function, that has state, set state, and ProMap. And it's going to just return a JSX with input type text and the value is the state, and on change, I'm going to take the event, I'm going to persist it, which is a reacting, and then I'm going to call set state, event target value. Like that. Yeah, it's good. And now I can use pro input, right? I could replace this with pro input, and I need to pass my input profunctor there, which I don't yet have. How do we build that? With just the pro map. With pro map, I just pick the to-do, so state.todo, and I need to unpick. So once I have the new to-do, I will end the old state. Let me just put these on different lines. Then I can, whoops, I hate this thing in front of me, this sort of autocomplete, yeah. New state of the parent. How do I do that? It's an object that has to-do is new to-do, and list is old state dot list. Okay, I'll let you look at that for 7 minutes. So input prof, yeah, it's there, and I can use it in the pro input. So I type here, and it updates the global app state. That's cool. And notice that, you know, my pro input thought that this state belongs to me, right? It thought that, this is my state, I'm just setting my state, right? So that's nice because the pro input thinks that this is all that exists, I only care about this. And it's the parent's responsibility to convert back and forth. Okay, now we need to sort of, upon pressing insert, we need to do something. We basically need to insert will clear this string and take the string and put it there, right? You can also quite easily write this as handle insert, which is going to be this function here. Yeah, we're going to set state. We're going to take the previous state, and we're going to set to-do to be empty, and the list is going to be the previous list concatenated with the previous to-do. Okay, and handle insert over there. So as I just, I'm adding it to the list. I just need to now render the list. Okay, let's make a pro list so we can really give this a try and see how far does this thing go. State and set state and pro map, and here we're going to, so state will be an array, so I'm just going to rename it so that you can follow it a bit more easily. It's an array. It's going to be an array. And I return unordered list, and I have there array.map, x, and the index of x. I'm going to create Lee with x inside it, and of course React wants the keys. That should be okay. And now I also need to create my list profunctor, which is promap. I need to pick the list, and I need to take the new list with old state and create to-do, which is old state.todo format for me. Sorry. And the list is the new list. Cool. And then I can use prolist over here with this profunctor. Okay. I'm mapping back and forth. And I think it should work. Sometimes, is it just refresh or what? Why? Can I ask for help? What's going on? It looks correct. I'm just going to restart my server. I don't know why this is going on. What? Save the changes. Thank you. There you go. Thanks, Anonymous. Great. So, okay, I have a very simple list. I just want to modify these A, B, and C's now. It's too simple. Let's make, instead of x here, let's put a pro input. It sounds so awesome, which is going to have some kind of profunctor state. And I need to create that profunctor state, unfortunately. Let's say prof is promap. Now I have the list, which is the parent state. This is the same thing as array, okay? And I'm going to pick list I, which is the one that I'm concerned about, right? And once I have, let's say, new x and old list, I need to create my new list. I'm just going to format this. Whoa, yeah? What? Yeah. Just putting them in nice format like this. Okay. So how do I do this? Here's how my array should look like. Let's say that old list is ABC, and let's suppose that x is B, and I, which is the index of x, is 1. And I want to create this array that looks like this, A and uppercase B and C. So I just need to create this array based on the old array. So I do dot map for every, let's say, y with index j. I return y, except if the index is the same as I, then I'll return new x. Okay, this might confuse you a little bit, but you know, you can figure this out if you look at it long enough. This works. This is just normal mapping of arrays. Okay, does this do any help? Let's see, A, B, C. Can write Alice. It works, yeah. Bob. And you see, everything here thinks that they are using local state. The pro input thinks that Bob is its own state. The pro list thinks that this array is all it has. And of course, the app has everything. And everything gets updated automatically. You can even add another layer of conversion. Let's say we're going to map the string to uppercase, let's say. And then when we go back, we do to lowercase, right? So then this input thinks that all of the data that it has is uppercase. It thinks. So I can write here. I'm not using shift, as you see, or you don't see. But the data is actually lowercase. And then once I add it, of course, the data was lowercase, so it shows us lowercase there. And you know, you can do all sorts of conversions as you want, and you can compose these as they go. Question. Oh, let me actually. Sorry, I'm doing this not so easily for you. But how does this work with like performance-wise, right? Like, if I change something deep in the list here, what does it actually do, right? Here, it's calling set state inside the pro input, which bubbles up to pro list, and pro list will bubble up to the app. And that app, this actually, we're using only one internal state. Like, use profunctor state is actually calling use state inside of it. So there's one top level React core use state. So every time anything changes, the whole thing will change, which is a bad idea for performance. It's true. But you only need to add a couple of React memo. So you add React memo to memorize this component. And you keep on doing this for all the other components. Really no brains required, just keep on adding them. Because the use profunctor state also uses memoization inside. So if you keep on doing that, there is, I made this whole thing. I just added colors to it. So the idea is that the color flashes if that component re-renders, and I'll just demo to you that only the necessary stuff are re-rendering because I added React memo everywhere. Okay, so I'll add A and B and C and D and E. Okay, so as I type here, only blue and orange will change. As you see, all the rest are not changing because their state didn't change. And as well, as I type here, only this first field is changing. The others are staying the same. And as you see, this one is the pro list. That's why its data also changes, as well as the global app also changes. But orange didn't change. It stayed the same. So that's okay. Performance is not, it's not unlike Redux, where you need to carefully do should component update and that kind of stuff. What are the benefits of doing something like this with set and state and set state and ProMap? Well, the benefits are that we don't have actions and dispatch and a singleton. We don't have all of those stuff. And as well as now local state is global state. So we don't need to think like, how do I refactor this to add this there and convert it back? All of this is the same concept. And if you ever wanted to do something like set props, where you receive some kind of data, but you want to set it also, now it's the same thing, because since props are the same thing as local state, set state is set props. There's less boilerplate. You don't have a big reducer with switch case, with actions, and things are very well encapsulated. That's, in my opinion, this really exciting thing, because we don't have a singleton to import. So for instance, imagine something like pro input. As you see, the only thing that it requires is React. It's not requiring anything from this library that I made. It just expects to get state and set state and ProMap. So you could take this as it is and publish it on NPM, and it just, you know, it will work as long as it passes state and set state and ProMap. Get it? So this is quite exciting, because in my opinion, you can then, instead of like composing reducers, you could compose components that are meant for state management. And they will do the conversions back and forth and that kind of stuff. This is really new, I think. So this idea came, I mean, I didn't originally come up with functional lenses in CycleJS. Someone approached me and asked, you know, how could we make functional lenses work nice in CycleJS? And I discussed with them a lot of time, and we figured out a really nice way of doing that. So I really want to thank the CycleJS community for convincing me that functional lenses are good, and they are actually really nice. I also thank Yellow Afi, who gave me some tips and some links. In particular, Don't Fear Profunctor Optics, a link that teaches the theoretical part quite easily, if you know some Haskell. And then Fantasyland is also one thing that I took. So basically, ProMap is compliant with Fantasyland's Profunctor. Anyway, if you want to try it out, use Profunctor State. I published already, and you can try it out. Of course, it's not production ready, because not even React hooks are production ready. They're also alpha. But maybe one day, as these things get standardized, maybe, let's see, maybe this will be one thing that you can start using. Okay? Thank you, and if you got confused or anything, or if any questions, just make some questions to me later. That's it. Thank you. Okay.
Yes. Is it on? Thank you very much. Andre. I still have some awesome chocolates for you.
Oh, thank you.
Yeah.
Nice. Very well.
Thank you very much. It was very funny, because the first time I saw the title, I indeed, like a lot of you, I only understood like one thing, state management. But it really is a nice talk. So
Great.
thank you very much. Another round of applause for Andre. If you have some more questions for him, he will be available in the living room for a little bit more than something like about 20 minutes now, because we have some time left.